Dear friends, I welcome you all once again to the decoding of quantum mechanics expedition. In the previous session, we have discussed how Einstein's theory of light quanta was based on flawed assumptions and how the photoelectric effect can be explained classically. This showed that light is simply an electric field wave with no particle nature. Detecting photon polarization simply means detecting the polarization of the electric field. Therefore, the absence of any photons does not lead to any entanglement. This dismisses the belief in the particle nature of light waves. To see whether the electron can behave like a wave, we'll discuss the historical development of the atomic model. Now it is necessary to understand each historical moment philosophically and logically. The current atomic model is the quantum atomic model, and it is interesting to know what students think about it instead of me. Sometimes a student asks, Sir, if all the electrons in an atom are moving in orbits or are expressed as waves, how can solid matter be formed from such atoms? No teacher can give a satisfactory answer to this question, which is a fact, and yet the idea that our body is made up of such atoms and can remain solid and strong is so absurd. If all the parts of the machine are flexible, how can such a machine stand firmly on its feet? Therefore, the idea that electrons in atoms move in orbits or can be expressed as waves is crazy. In the early days, it was thought that electrons in atoms moved in orbits. At that time, physicists were getting evidences that electrons did not move in orbit, but they completely ignored them. In fact, physicists at that time made very good conclusions with limited resources, but some clues were ignored, which led them in a wrong direction. For that, we have to start with Rutherford's experiment. We know that J.J. Thomson, British physicist, first discovered the electron in 1897 at Cambridge University, England, which was a constituent of the atom. This showed that the atom was not indivisible as previously assumed. Since electrons are negatively charged, Thomson reasoned that atoms must also contain positive charge to stay neutral. This led him to propose a new structure for the atom. Thomson in 1904 suggested that the atom is a sphere of positive charge with electrons embedded in it like plums in a pudding. It was the first model to include subatomic particles made electrons and inspired future atomic theories. Ernest Rutherford at the University of Manchester decided to investigate how alpha particles interact with matter to test Thomson's plum pudding model and to understand the structure of the atom. Under Rutherford guidance, Hans Geiger and Ernest Marsden experimented with gold foil between 1901 and 1911. The reason for using gold metal was that it could be easily thinned by hitting it with a hammer. They studied the scattered alpha particles by shooting alpha particles at 3 gold foils and found that out of 2000 alpha particles, 1 or 2 were deflected or returned. From this, they realized that there is a lot of empty space in the atoms and almost the entire mass of the atom is concentrated in its center and may be called as a nucleus. Also, the total positive charge of the atom is also concentrated in the center. This means that the electron must be distributed in the remaining empty space of the atom. Rutherford was very surprised by the result of this experiment as he realized that atoms are not like the plum pudding model proposed by the Thomson. Rutherford announced the results of this experiment at a meeting of the Manchester Literary and Philosophical Society in March 1911, and a paper was also published later in the May. At that time, he said that the atom is completely hollow, with all its mass and positive charge concentrated in its center, which he called a nucleus. He further said that if we were to make an atom as big as a church, the nucleus would be only the size of the fly. The atom would be neutral, meaning that its negatively charged particles, the electrons, would be scattered throughout the hollow sphere or hollow space, perhaps orbiting the nucleus in orbits like planets orbiting the sun. Rutherford may have wondered why small electrons do not fall into the nucleus. He may have thought that their circular motion around the nucleus was responsible for this, in which the centrifugal force and centripetal force were balanced, and so he proposed the concept of the planetary model of the atom. The wrong idea that electrons move in orbits, actually it is wrong. The wrong idea that electrons move in orbits in atoms was first advanced through this. The reason for saying it was wrong is that later in 1936 a statement made by Rutherford is very important. During a lecture in 1936, he remarked that it almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. This illustrates that despite the alpha particles colliding with the nucleus with considerable force, the nucleus remains stationary. Yet he entirely ignored the implications of this observation. This suggests that on one hand, there exists a complete vacuum within the atom, indicating that the nucleus is suspended at the center of the atom, and even when alpha particles impact it, it does not shift. Who was holding him in place of the center of the atom? Why didn't anyone think of this?
The gold leaf contains nuclei and electrons. Nuclei are positively charged, so they will repel each other, causing them to scatter. Electrons are negatively charged, so there is attraction between electrons and nuclei, and repulsion between electrons and electrons. If the attraction between electrons and nuclei and repulsion between the electrons are balanced by properly distributing electrons around the nuclei in atoms, then all nuclei can be stable. But for that, electrons cannot move in orbits. This was the first indication that electrons cannot move in orbits. But it is interesting that Rutherford noted this in 1936. Then the question arises why Rutherford or other did not notice this in 1911. In fact, Rutherford was able to guess how much space there is in an atom, and accordingly he could reason about how small the nucleus is. But it is wonder how he did not question how the nucleus is suspended in that space. It seems that at that time all the questions of the atomic level were coming up at once, which confused everyone. Again, there was a deep study of planetary motion, so it was initially assumed that this would also happen in the atoms with electrons and nucleus.
Even if they thought that electrons should not move in orbits and that electrons might be distributed around the nucleus, there is a strong attractive force between the nucleus and the electron, and to balance it, there should be a strong repulsive force between the electron and the electron, which was not understood because if there were only two electrons in an atom, as shown here, the distance between the nucleus and the electrons would be less than the distance between the electrons. So the nucleus could have pulled the electrons straight, which would have ended the existence of the atom. Even if they thought that electrons should not move in orbit, that electrons might distributed around the nucleus, there is a strong attractive force between the nucleus and the electrons, and to balance it, there should be an additional repulsive force between the electrons, which was not understood. They couldn't even imagine that something like this could be there. It seems like everyone was in big hurry.
But at that time, if it had been suggested that electrons were not moving in orbits, which is the fact, and that another repulsion force is needed to balance them. Let's find out what it is. Perhaps the atomic model we have taken in new term. But that did not happen. Even they did not leave this topic open to. They all remained firm on the belief that electrons were moving in orbits for the next 10 to 15 years.
It's a contradiction that how we keep saying proudly to our student that we are literally floating on the ground. There is a very strong force between the electrons in the atoms at our feet and the electrons in the atoms at the ground surface. So we are internally balanced from the ground. Actually, this force must be static, and if electrons are moving in atoms, then how this force could be static? How foolish it is that we keep telling our students that electrons are moving in the orbits. And going further, we tell them that electrons in atoms can be in the form of waves too. Then if that is the case, then we will never be able to explain how we can stand on the ground formed by such atoms. And all this is tolerated under the motto that no one understands the quantum mechanics. Later, the question arose that if electrons were moving in orbits, they would emit energy, causing their speed to decrease and eventually fall into the nucleus. Hence, the question arose over the Rutherford model. At the same time, another question was how atoms could produce electromagnetic waves or light waves of a specific frequency. Earlier in 1988, Rydberg had derived an empirical formula based on experimental observation to describe the spectra of the hydrogen atom where N1 and N2 are positive integrals representing the final and initial energy levels of the electron in hydrogen atom, and this formula could successfully explain the spectra of the hydrogen atom emitted. At the same time, in early 1912, Niels Bohr joined Ernest Rutherford in Manchester, England for postdoctoral research and to address flaws in the Rutherford's atomic model. This is another turning point in the history of physics. At that time, Bohr realized that if electrons in a hydrogen atom kept moving in certain orbits, then the spectra could be predicted according to Rydberg's formula. The only condition was that the electron did not emit energy while moving in that particular orbit, and that when it jumped from one orbit to another, it would emit or absorb energy in the form of electromagnetism equal to the difference in its energy. From that, he was able to predict the spectra emitted and absorbed by hydrogen atom. Everyone knows this history of which Bohr had published a research article in 1930. Of course, Bohr's atomic theory gradually gained importance because it could explain the spectrum emitted or absorbed by hydrogen atoms, but some things in it can never be accepted. Bohr says that the hydrogen atom has stationary orbits in which the angular momentum of the electron is an integral multiple of h by 2 pi, and in which the electron does not emit energy if it is moving. The electron has its own electric field, we know that, and when it moves in any orbit, that field will create ripples of the electric field in space, and they will be propagated in the form of waves. Due to this, the speed of the electron will decrease and eventually it will fall into the nucleus. So no one can save it from this.
Ripples are not created while it is moving in a stationary orbit. Then there should be no electric field with that electron, which is never possible. Therefore, if the electron moves in any orbit, ripples will be created and it will eventually fall into the nucleus. Therefore, the concept of stationary orbits cannot be applied under any circumstances. It is extremely wrong to accept this just because the mathematical numbers match to explain the emission of spectra of hydrogen atom. Secondly, Bohr says that when an electron in a hydrogen atom jumps from an outer orbit to inner orbits, its energy difference will be converted into electromagnetic waves, whose frequency is given by the dividing its energy difference by h, where h is Planck's constant.
That means the electrons does not need to oscillate at the frequency at which the wave is being generated, which is beyond our imagination. When Einstein came to know about this, he also said that Bohr would not dare to present his history. We know that in an antenna, the electric current, that is the electron, oscillates at the frequency at which the electromagnetic wave is desired. But at the same time, when electrons jump from a higher energy level to a lower energy level in an atom, an electromagnetic wave is generated. But the value of the frequency generated by the antenna is less than the value of the frequency generated by the atoms, but both are the electromagnetic wave. This means that if we increase the frequency of the current in the antenna, the frequency of the electromagnetic wave generated by it will increase. Also, if we reduce the value of the difference between the two energy levels in an atom, then the value of the frequency it produces will decrease. This means that we will get a point of frequency where if we want to produce an electromagnetic wave of a frequency below that point, the electron will have to oscillate, and if we want to produce an electromagnetic wave of a frequency above that point, the electron will have to jump from the corresponding higher energy level to the lower energy level. Again, we can't prove what needs to be done to produce a wave of the frequency exactly at that point. Is this possible? Friends, never. We know perfectly well that electromagnetic waves of any frequency can be generated by oscillating electrons, and the two different causes are not responsible for the same thing happening in the universe. And if this were the case, we would not have been able to apply any logic and predict what would happen next. When we realized that the electrons in atoms were responsible for generating electromagnetic waves, it was only then that we had to decide that the electrons in atoms must be oscillating at the frequency of that wave. This means that no electrons could move in around in the orbits in the atoms, and this subject had to be left open for research or for discussion. When Bohr's hydrogen atomic model was proposed, it was also considered for higher atoms. At that time, it was known that the helium atom has two electrons and their net orbital magnetic moment is zero, which means that the two electrons must be rotating in the same orbits but in opposite direction and at the same speed, which was never possible because they would have come close to each other twice while completing one orbit, and due to repulsion between them, they would not have been able to maintain the same orbit, due to which their net orbital magnetic moment could not have remained zero. Their net orbital magnetic moment was zero, which means that they were not rotating in orbits, but this topic was not never discussed widely.
Sometimes in history something is missing, but if the same thing is found in the future, it is forgotten because by then a lot of water has flown under the bridge. Even now, although it is important, the approach to looking it has changed. Similarly, between 1909 and 1913, the need for an additional repulsive force to keep electrons stable in atoms was discovered in 1927, but by then the approach to looking at that matter had completely changed. Therefore, its importance was not realized for the last 100 years.
In 1922, Otto Stern and Walter Gerlach performed an experiment. It is very important experiment to determine whether the magnetic moment of an atom associated with the orbital angular momentum could align solely in certain quantized directions, such as up or down, instead of any arbitrary angle as suggested by the classical physics or classical mechanics. For this, they passed a beam of silver atoms through an inhomogeneous magnetic field and saw if it split into two parts, and they found that it did. This also confirms the space quantization of the orbital magnetic moment of the electron. But in 1925, George Uhlenberg and Samuel Goldsmith showed that the splitting of silver beams that Stern-Gerlach had observed in 1922 was not due to their orbital magnetic moment but due to their spin magnetic moment of a valence electron in the silver atoms. At that time, it was realized that electrons in atoms have another motion which is a spin. Because of that, they act as a spinning magnet. But it was not considered that due to this spin motion, electrons acquire magnetic moment, and perhaps this could help electrons to stabilize in atoms. At that time, at least, it had to be accepted that the electrons in helium atoms were also involved in spin motion, which resulted in a combined spin magnetic moment of zero. Consequently, these electrons would be in opposite motion along the same axis, rotating at the same speed, located at the same distance from the nucleus. Due to opposite spin motion, magnetic repulsion between the electrons will be induced. Now net repulsive force is equal to the electric repulsive force between the electrons plus the magnetic repulsive force acquired due to the spin motion of the electrons. So net repulsive force is now increased. If the net repulsive force becomes equal to the net attractive force at a particular distance of the electrons from the nucleus, then the system becomes stable. It happens in the helium atom. Its overall electric field and overall magnetic field becomes zero. So this system is a stable called the helium atom. Atoms and molecules are formed in core of stars. Assume first nucleus of helium atom is formed in the core of the star. To be neutral, it attracts two electrons. When two electrons come close, electron repulsion will increase, and to reduce it, they will get triggered into the opposite spin. This is a crucial event in the formation of atoms. If it does not happen, atoms can never be formed. It causes to produce the magnetic repulsion between them. The net repulsive force becomes electric repulsive force because of the charge, magnetic repulsive force because of spin magnetic moment. Actually, the electron repulsion must be due to the interaction between the radial components of the electric fields of the electrons, and magnetic repulsion must be due to the interaction between the tangential components of the electric fields. This is a topic of further discussion which is very important regarding the absence of magnetic monopoles in the universe. If the net attractive force at any position of the electrons is greater than the net repulsive force, these electrons will get dragged toward the nucleus, which causes to increase the electron repulsive force further. To reduce it, spin speed of both electrons will increase, causing to increase the magnetic repulsion. A point will come when both attractive and repulsive forces get balanced. The electrons get stable at a particular and equal distance from the nucleus. Thus, no spin motion when electrons is outside of atom. Spin is acquired to reduce the electric repulsion between the electrons in atoms. Spin speed is not a constant. Spin is not intrinsic property of the electron, and it is also clear. J.J. Thomson had not found any spin when he discovered the electron in 1897. He was doing the experiment on the deflection of the cathode rays, means electron beam, by putting magnets here. At one instant, he might have put one magnet at the side of the cathode ray tube. At that time, the electrons will be deflected in upward direction. If electrons in the electrons beam are in spin motion, they will act as a tiny magnet. And if S pole is here of the one magnet, and electrons moving in upward direction due to the electric charge and due to the magnetic field of the magnet, and if the electron moving in this direction, it has S pole towards this magnet at that time it will be deflected in opposite direction, so we will go here. Electron magnetic moment is perpendicular to the magnetic moment of the bar. At that time it will go straight here, and if the electron has a n pole toward the s pole of the bar magnet, at that time it will get pulled toward the bar magnet. So on the screen a straight line should be produced here, but we found that there is only a spot, that is single spot, means electrons are not deflected due to magnetic field. And it is also possible for J.J. Thomson to find out is there any deflection due to magnetic moment. He did not observe, indicating that the electrons was not acting as a tiny magnet, means they did not have any spin motion. If they did have spin motion, then the CRT based TVs will not be have not be worked. So from the history also it is clear that spin motion is not intrinsic property. Now in the Stern-Gerlach experiment, we pass the electrons using the electron gun as a beam through it. It will not get deflected as like such splitting as observed by for the silver beam. So it clearly indicated that these electrons escaping here are not in spin motion, means when the electrons are out of the atom, they do not have spin motion, means the spin motion of the electron is not its intrinsic property. It is acquired to balance in the electrons in the atoms. EM generation by electrons in helium atom. In a helium atom, there are four forces to balance the two electrons, a total of two attractive forces acting between each electron and the nucleus, and the two repulsive forces acting between the electrons, consisting of an electric repulsive force and magnetic repulsive force. Due to some external interference such as increase in temperature or some other cause, when both electrons are displaced from their balance points toward the nucleus, the electrorepulsive force will increase. To reduce it, the speed of spin rotation of these electrons will increase, which increase the magnetic moment of both electrons, which in turn increase the magnetic repulsion between them. However, as the radial component of the electron's electric field diminishes, the attractive force also decreases alongside the electric repulsive force too. Nevertheless, due to the increase in magnetic repulsive force, these electrons will be driven back toward their balance point or equilibrium points. However, due to the mass of the electron, they have gained a momentum, meaning that the electron will continue to move forward without stopping at the balancing point. As a result, the electric repulsion force between the electrons decreases, which in turn reduces their rotational speed, which in turn reduces the magnetic repulsion between them. As a result, the electrons are pulled back toward the equilibrium points, specifically the nucleus. Thus, both electrons oscillate radially around their respective balance points to establish the equation for the effective force exerted on the electron. It is essential to first derive the equations for the four pertinent forces, a task that has yet to be accomplished and is expected to be quite challenging in the light of a new comprehension of atomic structure. Nevertheless, this will represent a significant advancement in understanding of atomic structure. The effective force will decide at what frequency the electrons can oscillate around that point, which will be the natural frequency of oscillations of those electrons at that balance point. These oscillations will be simple harmonic oscillations. Again, as the electrons oscillate, they will both approach the nucleus at the same time and both move away at the same time, meaning their motions will be synchronized. When the electrons oscillate, since the electrons have their own electric field, they will produce ripples of the electric field, which will propagate in the form of electromagnetic waves. These waves will propagate in circular form or in ring form around the balance point in a direction perpendicular to the axis on which the electrons is oscillating. These waves produced by the two electrons will have a phase difference of 180 degrees. As the wave propagates its amplitude should inversely proportional to the square of the distance of the field point from the mean position of oscillations of the electron. However, due to some particular environment which requires further research, if such a wave propagates in one direction, that is in the form of a light ray, its amplitude should not decrease no matter how much distance it travels in space. If the helium atom is in its ground state point, A1 and B1 will represent, that is the 2 point, initial balance points of the electrons, with F1 denoting the natural frequency of oscillations. Experiments have demonstrated that the helium atom can emit electromagnetic waves at multiple specific frequencies. Therefore, the two electrons in this atom can balance at a certain points at a certain equal distances from the nucleus on either side, where the natural frequencies of the electrons oscillations are different. In a helium atom, there are total electrons 2. They will form a first cell, and as the total magnetic field or net magnetic field and net electric field also balanced, because of that atom is stable. But now there are two possibilities of the spin motion. One is this spin motion, that's electron in opposite direction in spin motion, but the magnetic moment is pointing inward direction. Now here the spin motion is opposite to that of the previous, so magnetic moment is out of directed out from the nucleus. So there are two possible combinations. Now we can refer this spin as a spin down, and this can be considered spin up. So both electrons has spin up here and both electrons is spin down. Means in first shell there are two electrons which is considered 1 as 2, and with respect to the nucleus, spin here is either down or either up. Now higher atoms are formed from the helium atom. In nucleus of helium atom, if one neutron and one proton gets added, at that time it will require another electron to balance the charge. So the E3 electron, third electron is get attracted to the helium atom, so it will form a next new atom which is lithium. Now this E3 electron will not come to the cell first, that is 1s2 cell, because the electric field of both electrons will keep away the electron E3. So E3 electron will be balanced in the plane somewhere here at a particular distance. So this distance must be greater than this distance of these two electrons. Now the first two electrons have effective electric field which has circular, means a tangential component 2. This tangential component 2 brings E3 electrons in also spin motion. Now the effective spin motion will be opposite to the effective spin motion of both the electrons. Also, it is clear that as these two electrons will not allow the third electron to come at their level, because of that it will stay away from the first cell. So it is nothing but formation of the second cell, we can say that. Now this electron is unpaired, because of that net magnetic moment of this atom is non-zero. Further, this cell too can be shown as, and it has a larger surface area than the first cell. So number of electrons more can be accumulated in this cell. Now, as this is first possible combination, the third electron will have such a spin motion, that is these three electrons in the lithium atom will have this spin configuration. All the electrons has down spin, we can say here, and another possible combination is this, here all the electrons have up spin here. So these are the two possible combinations for the lithium atom. Now in the beryllium atom, it consists of 4 electrons. Means in the lithium atom, nucleus of the lithium atom, if one proton one and one neutron gets added, so the lithium atom will attract another electron which is E4 electron. Now there is already first cell formed which is 1s2 of the first two electrons, which is actually from the helium atom. They are formed in the helium atom. And later what happens? This electron is from the lithium atom. So after the formation of lithium atom, there will be formation of the beryllium atom. So when the fourth electron gets attracted toward the nucleus, it will reside in opposite side of the E3 electron at the same distance. That is, this distance and this distance will be the same. Now this is nothing but a formation of second cell. Now it can be considered as a subcell which has a 2s2 name in the usual quantum mechanics, and two electrons are here formed. These two electrons will be equally spaced from the nucleus, but their distance will be greater than the distance of the first two electrons in the first two cells. Now consider another heavy atoms or higher atoms, which is nothing but neon atoms. Now we know that neon atoms consist of 10 electrons. So as usual, two electrons will be in one s2 cell, which is not shown here. Second cell consists of 8 electrons because second cell has increased a more surface area, and from there will be two subcells. In the second cell, two subcells means 2s2, that is 2 electrons will be formed here, a pair which are also not shown here, these electrons. And remaining 6 electrons are shown here, they will form a pair. So total 8 electrons are accumulated in the second shell, but distance of the two electrons from 2s2 cell will be small than the distance of the electrons from the nucleus in the 2p6 cells. So it has two subcells. So these 6 electrons are arranged in pairs such that one pair is here, another pair is here, and perpendicular to this there should be last pair here. All the electrons are balanced, so net magnetic moment will be zero here. Net charge is also effective charge is a zero. Net magnetic moment of the system is zero. So system is quite stable here. Now these are the electrons. The 2p6 subcells are in spin motion. One pair is here, another pair is here, and this pair is perpendicular to the first two. We expect that, but it is not quite clear since this spin atom model is yet to be developed. Now consider molecule here. Now we know that to form molecule, two or more than two atoms of same kind or of different kind come close to form a stable system. The need of formation of molecule is to become electrical neutral and net magnetic moment zero of the system. And here a simple molecule we first consider, which is HCl molecule. In the chlorine, we know that there are 17 electrons, means two electrons will be 1s2 cell, two electrons will be 2s2 cell, 6 electrons in 2p6 cells. All these electrons are not shown here, they are in pair. Now the third shell is formed. In the third cell, there are 7 electrons remained. First will be again 3s2 subcell in which two electrons are balanced. 5 electrons are shown here, which are in the 3p5 E, means 3p6 subcell in which 5 electrons here. So these are the 5 electrons. From them, 4 electrons are balanced, but one electron is not balanced, not paired. Now a hydrogen atom is here, that is electron P17, last electron of the chlorine, may come in spin motion of hydrogen electron. So here is a hydrogen atom. And so the net effective magnetic moment of this pair also becomes a zero. So the system's net magnetic moment becomes a zero here, and the hydrogen atom is always at this position. So this hydrogen atom is not revolving here and not revolving here and so on. All the electrons are have all the electrons have fixed positions, not they are reacting as waves or not they are in circular motion. So this is the structure of HCl molecule. So in the HCl molecule, these electrons in the 2p6 subcell of the chlorine and hydrogen, they are in spin. This is hydrogen electron which is paired with A17 electron of the chlorine, and this should be egg-like structure. This is one pair, this is another pair, and perpendicular to both pairs, this will be This pair should be there. Now consider water molecule H2O. It consists of two hydrogen atom and one oxygen atom. So now we know that in oxygen atom there are 8 electrons. So 2 electrons will form first cell, that is 1s2, and second shell consists of two. First subcell 2s2, there will be 2 electrons and 4 electrons are remaining. So these 4 electrons, first one pair will be formed here by the 2 electrons, and the remaining 2 electrons will form a pair with a hydrogen atom. Since to complete oxygen's this subcell, it requires 6 electrons. So 2 electrons will not remaining 2 electrons will not form a pair with each other, but they will break and they will form pair with hydrogen atom. So this electron is in spin motion with this hydrogen electron spin, so it will form pair and net magnetic moment becomes this zero of this pair. Also, this electron will form a pair with one electron, that is hydrogen electron, and that pair will also net magnetic moment zero. So the system is stable, and these two hydrogen atoms will be at a particular position in this molecule. They will not revolve, they will be steady, and the angle between this should be also constant at normal, uh, means at a low temperature. And this I think it is near about 100 and maybe above. These are the spin motion of the electrons in water molecule. So this pair is first formed electrons from the oxygen, and this is electron from the oxygen, and this electron from the one hydrogen atom. There is one formation pair, and this is again another formation of the pair. This is oxygen electron and this hydrogen electron. So first pair is here, second pair is here, and third pair is should be perpendicular to the both these. So these are the spin motions shown here. Now consider the carbon dioxide molecule. It consists of two oxygen atoms and one carbon atom. In oxygen atom there are 8 electrons. 2 electrons will form a first cell, which is 1s2, which is not shown here. 2 electrons will go in second cell, forming with two subcell 2s2, which is also not shown. But 4 electrons, they will go in the 2p6 subcell of second cell, which are shown here. So these are the 4 electrons, 1, 2, 3, and 4. Now in the carbon atom, there are 6 electrons. 2 electrons will be in first cell, that is 1s2, which is not shown here. They will form pair. And second cell there will be 4 electrons. Two will be in 2s2 and two will be in 2p6, means 2p2. So what will happen here? That is, these are the 4 electrons from the oxygen atom in 2p6. From that, 2 electrons will form a pair and two will be unpaired. These 2 electrons will form a pair with carbon atoms. Similarly, this in other oxygen atom, 2 electrons will form one pair and two will be remain unpaired. These electrons to form a pair with carbon. But actually, carbon has only uh, 2 electrons in 2p2. But the 2 electrons of 2s2 cell will also break. They become free to form a pair with these two oxygen atoms. So here the second cell of the oxygen now considered can be filled with 6 electrons who are already inside the in the PS2. Here the second cell of this oxygen atom is filled with taking 2 electrons from the carbon also. So this second cell is completed of this oxygen. Second cell is also completed of this oxygen. And 2 electrons are given by the carbon to this, and 2 electrons are given by the carbon to this atom. So carbon considered as a donor, and oxygen can be considered as a acceptor. So this total system is now balanced. All electrons are in the pair. Overall electric field is zero and overall magnetic field zero. Because of that, this system is quite stable. Now we can see how the electrons are in spin motion in the carbon atom and in the oxygen atom too, that is in the carbon dioxide molecule. So these are the carbon electrons, and this is also carbon electrons, and these four electrons are of oxygen. These four electrons are of oxygen. Two electrons are the oxygen already formed paired. Two electrons from the oxygen already formed paired. But these two electrons get balanced with here, and these two electrons of the oxygen get balanced with carbon. So this is called a double bonding of the in the molecule. So relative spin motion is shown here. And from this, the picture is clear that all the electrons in either atom or molecules are stable and they have fixed position in their atoms and their molecules too. They are not revolving in the atom or molecule. Also, they are not behaving as a waves in the atom or molecule. They always behave as a particle and the spin motion is responsible. But yet we don't know, means the last 125 years we don't know what is the picture of the electrons in the atoms and molecule. If the technology becomes advanced at that time, we may be able to directly take photograph of such molecules and we may be able to locate their electrons in that photograph. Where are they in the outer orbits? At that time, we found that such positions of the electrons, and at that time we concluded that the quantum theory which we are carrying from last 125 years, which predicts wrong that electrons are behaving as waves there. So this is totally wrong. Electrons are not behaving as a waves. And also, the quantum nature in the atoms and molecules or in the matter is to because where the electrons are balanced from the nucleus and what are the forces acting on them, they will decide at what frequency this electron to be oscillated. So this type of atomic model may be considered as a spin atomic model. Let us discuss what happened in Stern-Gerlach experiment done in 1922. Stern and Gerlach were expecting that electrons are behaving in circular orbits. So in silver atom, the last electron will be in outermost orbit, 47th electron. And either maybe it is revolving in orbit in this direction or in this direction. When it revolves in this direction, it will act as a magnetic moment or a magnetic bar as like such N pole here, S pole here with center of these two pole is the nucleus. When it revolves in opposite direction, it will act as a magnet or magnetic bar whose center is the nucleus. When such atom will pass through the inhomogeneous magnetic field, now N pole is in upward direction. At that time, the N will be repelled from this. So the atom, silver atom will go in the downward direction. It will produce impact here. When this atom at this position travel through this inhomogeneous magnetic field, at that time, S will be attracted toward the N. So it will go in upward direction. A hit here means it will produce impact here. But when this magnetic moment or magnetic bar is perpendicular to this poles N and S pole lines, at that time it will go here in this direction. It will not deflect it. It may produce here impact means at the center. So any other alignment will produce either here, here, here. So maximum such type of uh, impact should be produced on the screen here. So such observations they were expected at that time by the Stern and Gerlach. What they found that such type of means only the atoms are either deflected upward or either deflected downward. Why? Why? Because this can be understood using the spin atom model. We know that the 47th electron is the last electron which is in the outer shell and it is single electron. So it will be in a spin motion either here in this direction or here in this direction. When the spin motion of the electron is in this direction, at that time N pole be here outside, S pole be toward the nucleus, and center of this bar magnet, that is these two poles, will be the electron, not the nucleus. When this electron revolves, that is in spin motion in this direction, at that time it will again act as a spinning magnet where N pole toward the nucleus, S pole outside the atom, and center of these two pole is the electron, not the nucleus. So all inner electrons are balanced. So there will be no net magnetic field because of that. Only magnetic field will be because of this. positions. So now when such electron passes through the inhomogeneous magnetic field, here is bar magnet is similar things to be attached to the atom. So this will get repelled from this. So it will turn here in this direction. Only the atom will go down and this it will go here and it will strike here in this position. That is in the lower position here. When such atom passes through this inhomogeneous magnetic field, yes, the yes pole of this magnet is in upward direction. Because of that, it gets attracted here, and so it will go in upward direction, produce the impact here. But now this magnet is not in either up or either in this position, but suppose it is here or here. In such a case, that is suppose the n pole is here, s pole is here. At that time, when it passes, at that time the outer n pole will be pushed here in downward direction. So what will happen? It will push in downward direction, so it will go here and it will get impact. And for this, it when it goes here, when S pole is here, so that time the S pole will be attracted in upward direction. It will turn here, and S will be upward here, and so will give its impact. So whatever the position of this electron in the atom here, or wherever it will either get up or either get down because the tiny bar magnet is attached to the atom of that side. So we will get such type of impact, and that's why the Stern latch absorbs such type of impact because of the electron is in spin motion, but it is at a fixed position in the atom. This has to be understood today. Now, how the electrons in atoms can oscillate, we can see here. You must consider particular pair of electrons formed in atoms. So this pair is close to the nucleus. Next pair is this, and that is another pair which is away from these two. So actually, the frequency of this pair must be high as it is close to the nucleus. So balancing forces must be strong here. So this frequency will be low than the first previous pair, and oscillating frequency of these two electrons should be low again that of the previous two electrons pairs. So now we can say that when we elaborate or expand an atom and we give an impact to that using that as like a hammer. So what will happen? All these electron pairs will oscillate with their natural frequencies. So first pair is oscillating with high frequency, second pair is just a low, and third pair is oscillating with again low frequency. So whatever with increase in temperature of atom are given an impact to the atom, all these electrons should oscillate according to such motions, that is toward the nucleus and away from the nucleus. So because of that, electromagnetic waves are created. While solving the black body radiation or hot body radiation, we have to take into consideration how the electrons are oscillating at that time. We may get a clear picture of that. Now consider the X-ray production. We know that in X-ray production, electron with high kinetic energy gets incident on the target. Now here this electron is going here. When it incident on an electron which is at inner cell, at that time it will get oscillate with its own frequency, and this frequency is of X-ray range. At that time this oscillation will produce X-ray here, and the coming electron will go away out from that of the atom also. Means this must be happening for the production of the X-rays here. Now people think that that is when electron enters in the atoms, it will go here and it will stop here. So this difference of energy, kinetic energy, converts into X-ray or photon. This is not true. Actually, it impacts on the electron at inner cell, whose natural frequency of oscillation must be of the frequency of X-rays, and it oscillates the coming electron. After colliding, it will lose no doubt kinetic energy, but it will go away. It may happen that this coming electron will first collide on this electron, then later on this, later on this, later on this, and may go in this direction. At that time, these electrons will get oscillate with their natural frequency, so it may produce Four electromagnetic waves may be produced. It may have low, it may have X-ray, it may have X-ray again, it may be again low. Such spectrum can be observed, should be observed in such a case. So this is the actual what is happening for the in the time of X-ray production, and which we have to understood. Let us say what happens when an atom absorbs a particular electromagnetic wave or a light wave. We assume that using the quantum mechanics, when an electron in an atom jumps from higher energy level, say E2, to lower energy level E1, then this energy difference gets converted into a photon, and if this energy difference is equal to hf, then the photon of energy hf is generated, which is associated with the light wave or electromagnetic wave in this process. Now the electron from E1 to E2 will go only when this amount of photon he gets absorbed, or this amount of particular energy he gets absorbed here. Otherwise, it will not go from this to this level. So it is very difficult to understand how the electron understands the incoming photon is of the energy hf, which is required to go him from E1 to E2. It is beyond our imagination. Also, we know that Einstein said that partial energy of a photon can be absorbed by the electron. If hf2 is the energy of a photon which is greater than that of the hf required to go from this to this. So if Einstein is correct, meaning that required energy from that the electron can absorb and go from E1 to E2, but this is not also observed. Further, any low energy photons cannot be absorbed by these electrons. Why this is happening in the atom? As electron is a single particle, it has no any mechanism to decide or to take decision to do all this process. Actually, the things are different there in this process. We can understand here. This light here is nothing but it is electromagnetic wave, and we know that electrons are balanced from the nucleus at a particular distance with balancing forces, and they have natural frequency of oscillations at that point. It will be determined by the balancing forces. So if this electron at this point is balanced and it oscillates with frequency f, then it will produce, when it oscillates, then it will produce electromagnetic wave of a frequency f only, which is actually light wave. When if it is a rest, suppose not it is oscillating, and another light wave is coming here, and it gets interact with the electron, so then the electromagnetic or electric field of the light wave will try to isolate it. If the frequency of the light wave is the same as the frequency of the electron, which is natural frequency here, at that time the electron will come into oscillation because of the tuning of the force. Otherwise, if this frequency of the incoming light wave or electromagnetic wave is different from that of the natural frequency of the electron, electron will not oscillate such that the wave cannot be absorbed. Why? Because when the wave electric field of the wave applies force on the electron, the oscillations of the electron in opposite direction to the field direction. Since electron has, we assume, negative charge, because of that, when electric field of the wave is in up direction, at that time electron will go in a downward direction. So electric field also produce, and this electric field when it oscillates means it is electromagnetic wave, and the electromagnetic wave produced by the electron and incoming electromagnetic wave, there will be 180-degree phase difference. Because of that, net wave from this process is equal to zero. So this total wave gets absorbed here, and this is nothing but the tuning of the two frequencies. One is the incoming frequency, another is the natural frequency of oscillations. If the tuning happens here, at that time only the wave will be absorbed here. And this is nothing but the case. Otherwise, there is no any absorption or emission of photons and so on. So this is the way to understand the absorption spectra. If the frequency of that wave is different, then there will be no tuning. Because of that, the wave will not be absorbed, it will go straight. Since the wave produced by this and the wave of this, they will not cancel each other. Because of that, we will observe here also. This is the case of the absorption spectra, but we are far away from the understanding the what is the fact happening there. For further understanding or information, I request please read one paper that is on the true origin of quantum nature in atoms, a missing story. It is preprint of the paper published by ELO Psi in November 2025. The way of this paper is this here. You can also read additional paper that is actually explanation of photoelectric effect published by IEEE in April 2025, which divide this. There is also one book published by me, which is Light Quanta Einstein's Big Mistake, and which is available widely on internet.
Look friends, in any atom electrons do not move in orbits and do not behave like waves. In atoms electrons are balanced by their spin motion, therefore such model may be referred as a spin atomic model. Each electron in an atom has a natural oscillation frequency that depends on the strength of the forces balancing the electron from the nucleus at a particular point in the atom. Therefore, an electron can only oscillate with that natural frequency of oscillations at that point in that atom. Electrons can balance at a different but specific points in atoms. Therefore, atoms can produce electromagnetic waves of different but specific frequencies, that to be noted here. The spin atomic model is useful for searching where the electrons are balanced in the atoms and molecules, but a mathematical setup is required to develop a spin atomic model. Since no light behaves like a particle and no electron behaves like a wave, quantum mechanics is based on flawed assumptions. That is why its predictions are difficult to understand, which are also flawed. Quantum entanglement is impossible. Quantum mechanics is just a mathematical setup or mathematical framework that is not connected to reality. Einstein was always saying this thing. Friends, thank you for being with me.